links to like, do you and your spouse match pheromones and love pheromones and stuff like that. So a human pheromone defined is a chemosignal that triggers an emotional or behavioral response in another individual. There were a couple of studies carried out to kind of to actually identify that there are pheromones. In one study, women were able to identify pads exposed to other women's state of fear, and they were able to pick up the fear from smelling the pads. And then testosterone levels in men decreased when they were exposed to the scent of ovulating women. Oh, I'm sorry, it increased. Sorry. And then it was sniffing the women's negative emotional tears decreased their testosterone levels. So I just want you to take a second and imagine. Sorry, you know guys get all uncomfortable when girls cry, so that's probably why. So we wanted to know if you could detect and approximate what those chemicals were. And the question led us to the biochemistry and psychology department. We joined forces and we did a lot of research beforehand to see if there had been any research done prior to it. And our primary reference was by a man by the name of George Preddy, and he did a lot of research extracting volatile compounds using a GCMS. And what he found was that there were 92 common chemicals among participants from 58 spiny fibers. So, what is a spiny fiber? It's a solid phase microextraction. And what that is, there's a little picture up in the corner over here. It's got a little needle with a polymer coating that can pick up volatile compounds in the air. And when it's exposed to an injection port in what's called a gas chromatography mass spectrometry, it's really hard to say, you can take those chemicals off and find out what they are. So what the GCMS is it can carry, well, I'll just show you a picture of it here. It's kind of confusing, but just accept it. What you do is after you take your sample, you get your spiny fiber and you expose it to an injection port. See right here? And that's heated to a certain temperature that it will just knock off all the chemicals that the fiber absorbed. And then once that's done, so we usually leave that there for 2 minutes. After that's done, a helium gas flow is sent through this column right here, and the column is heated. And what that does is so the helium carries the molecules through the column, and based on the chemical's size, the smaller they are, the faster they'll come out. So you can think of it as like a race almost. So they're all racing through this column, and some of them can get stuck in there, and that's why you just increase the temperature gradually. Once they make it through this column, there's an ion source right here, and they shoot electrons at those chemicals and break them apart so that they can be detected in the mass spectrometer right here in this filter. And so it's got like a magnetic field, and there's a lot that goes into it, but I won't bore you with that. So our method was we got participants to rinse off their arm just to remove any kind of anything that could be on there, like perfume or lotion or something. And then we had them walk up and down the stairs for about 5 minutes. And this was just to kind of get, for lack of a better term, get their juices flowing. And after that, we exposed one of the spiny fibers to their arm for 30 minutes. And then after 30 minutes, we exposed it to that injection port where it could run through the GCMS. And then the data was displayed on a computer in the spectrum, and then we could analyze what the chemicals were. So this is what the spectrum looks like, and what the software allows you to do is you can integrate these peaks, and it provides what chemicals there are. It gives you 3 guesses, and then it gives you a number to determine which one is its highest guess. So with this method, again, we were comparing it to that Preddy method. We ran into the problem we weren't getting any chemicals that he was showing. And so we couldn't figure out what we were doing wrong. We've been following this method exactly. We even reached out to him to kind of touch base with him and see what we were doing. And I mean, we really couldn't figure it out. So then we decided to update our method, and instead of just using one fiber, we used 3 spiny fibers on the same participant's arm. So that way we could take the average of all 3 fibers and see what chemicals were more likely to be there. So we just did the exact same method as before with the participant walking up and down stairs, and then we had the 3 fibers. And this way, again, we got 3 separate spectra, and this is like one participant's run in the 3 spectra from the 3 separate fibers but the same run. Does that make sense? Yeah? So you can see it's pretty similar, right? And so then what we did was we found the common chemicals between at least 2 of the fibers and then in all 3. And what we came out to be after we got 18 participants, and we used males because females had a bunch of different chemicals. It was really weird. So you can see we got a bunch of different chemicals, and you can see the percent number, the percent of the chemicals that were shown in the individuals. And then up here you'll see this is the CAS number, and what that is it's just a generalized database where you can identify like exactly what the compound is if you want to just cross-reference it. And so from all this data, we found that there were the top 5 most common chemical compounds emitted from people were these 5. And we found that there was, so again, out of 18 participants, all of them had this, or these 3 chemical compounds, and then 94% had the decanol, and 83% had the middle. So our conclusion, the next step is we're going to run known samples of those compounds through the juicy mesh just to make sure that's exactly what we're getting, just to touch base, I guess. And then we want to further this research and implement emotions in there and see if there's different chemicals emitted based on feelings and stuff like that. And so just a special thanks and acknowledgments to all the students who have currently and previously helped out with this experience, because like Dr. Scott was saying, there's been a lot of time put into this. And thank you to our advisors, Dr. Miller, Scott, and Timothy, and biochemistry and psychology departments, and BYU Hawaii.
Great. Thank you very much. Any questions?
In the beginning, did you say that Freddie used 58 different spinning fibers?
Yeah, I'm not gonna lie, I think that was just a typo. He had 58 different people.
Okay.
Sorry.
Alright.
Yes.
You said at the end that your next step was to run just straight samples of like and all that jazz, but then after that you said to try it with people with different emotions.
Yeah, so, yeah.
So how would you go about doing that?
We've kind of talked about this, and we'd probably just show like a scary movie, and yeah, it's pretty basic.
So how would you link to these 5? Okay, so these 5 chemicals that you've identified. So basically, maybe I missed that. I apologize, Freddie, but to what physiological or psychological function are you linking these chemicals to, or this
It's
is just in
neutral.
general?
Yeah, just neutral.
So this is something that is volatile,
Mhm.
coming off of, but it's not linked to anything like a specific function for emulsion?
No, not that we've seen.
Okay, so this is like, I would say it's like a baseline.
Mhm.
Okay.
Can you go back to the big table with lots of different numbers? There we go. Can you go through these a little bit and kind of explain what these numbers mean?
Okay, yes. So,
You told us what the CAS numbers mean,
yes. So
and the left column is just the lists of the chemical names,
yeah,
right?
for the names. And then the chemical percent. So out of 18 participants, the percent of those that had these somewhere in their samples. And then this one is the percent that had these compounds in their top 5 chemicals that we found. And again, that was based on when you run the GCMS, it gives you a number, like a qualifactor number to determine how accurate the database thinks it is. And then since we have the 3 spiny fibers, these are just the percentages in each of the fibers. Does that make sense?
Percentages in each of the fibers, meaning like 3 SPMEs. Oh, it was,
Yeah, so like in spiny number 3, 67% of the time this one showed up, and then it didn't show up in these 2 spimies.
are you sure?
Yes.
You're sure?
I think so. Now I'm questioning myself.
Well, I mean, I'm sure it can't be that, because I would have gone crazy if that was the case, right? Because if we found that one SPME was always emitting one compound and it wasn't the other 2, I think that means it's showing up 63% of the time in all 3 SPMEs, right? I think that's the number of SPMEs that it shows. We'll have to take a look at that, because, I mean,
Yeah, I think
Well,
I'm pretty sure that's what we were recording
oh,
when we were writing it down. It's like how many speakers is showing up in.
but that does make us wonder. We'll have to double check, see what we know, because
I'm
a
pretty
lot
sure.
of this data was collected and helped out by who?
Aaron.
Aaron, yeah, yeah.
Well, that's embarrassing. Sorry, I should have
No, that's fine.
tipped it out better. Any other questions?
So you said 58 people were tested, right?
For us, we only tested 18, but with the reference articles we were using, he had tested 58.
So you tested 18 in each 3 SPMEs for each
Yes.
person, right?
Yeah.
So that's good, okay. Okay, so I'm still trying to understand the table. I mean, I'm slower than the rest.
That's okay.
So found in top 5, you mean the top 5, meaning the top 5 chemicals that you've identified? Or this is
Yeah,
the top
so-
5, what? Sorry.
So we had the list of chemicals, right, from one person, and then there's a qualifactor number that determines how accurate the GCMS is.
Mhm.
And from that, we took the 5 chemicals that had the highest qualifiers.
Parameters.
Okay,
Does that make sense?
right.
And so then out of 18 participants, 33% of them had this in the
Okay.
top 5.
In the top 5. Oh, okay, so 33% of the 18 participants had that chemical in the top 5. Okay.
Yeah.
And then the 3 SPME mean that this was found in 67% of the time in all 3,
Yeah.
and it never was found in 2. I'm looking at the first one.
Yeah,
Never found
Oh,
in 2,
yes.
and never found in 1?
Yes.
no, that's,
No. It was found in all 3 species, not in just one. It was found, yeah, it was found in all 3 of the spiny fibers, rather than just one of the spiny fibers or 2.
Or in 2? Okay.
but that, we have to
Okay, let me
double check that.
Let me backtrack. So the chemical percent, so 17% of the people showed this compound out of 18 of them. Out of this 17%, 33% of them had it in their top 5 chemicals.
Okay.
Then with the fibers, yeah, 67% of that had it in all 3 fibers.
But none of them had them in 2. or one. That's the part that doesn't make sense.
Yeah, that's the part that doesn't make sense.
Because,
Right.
you know, the percent should decrease, it should start from 100 to less than less. Because all of them had it in one, some of them had them in two, and even less had it in all three. Because how come they all will have it in three, but then none of them will have it in two, and none of them will have it in one?
Yeah,
So there might be some, I don't know, some data
yeah, honestly, that's probably just
variation
my
thing,
bad.
like, no, but that's okay. I mean, obviously you might have to review that just to identify which ones are the top 5, because that's what you use to figure out which ones are the top 5 compounds that you've identified, right?
Not those last 3 rows, though. Those last 3 columns aren't going to influence the resulting top 5, but
Right, so you might want to delete that part, or put it in another graph so it'll be a little bit clearer. 'Cause
Yeah.
I'm not
or
totally lost.
just talk with Aaron and try to figure out what's going on there.
So that part to be continued.
There you go. Nice, smooth transition.
So can you explain to me how the mass spec decides to give it a high qual factor?
Yes, so so after it ionizes it and then it detects it, right, it's shooting it through that detector, and we're comparing it to a database that's already programmed into the computer. And so depending on the mass of the different parts of the ion, it can determine how closely it resembles the same detections from a different chemical that's already preloaded in the library. Does that make sense? Or,
I don't know. That make sense, guys?
Are you trying to say how good of a match it is?
yeah,
Okay.
basically.
Yeah. Is that what you're doing, right?
Yeah.
So it compares the mass with the theoretical mass of a compound and says this gives you the best match with this compound, the second best is with this compound, the third best is this compound. So basically, that's what you're trying, right?
Yeah.
I don't want to put words in your mouth, but
No.
I'm just trying to.
You're fine. So, yeah, because with mass spectrometry, it produces a chromatogram, and it gives, well, I just don't want to explain too much and just over confuse people, you know, but it has a separate spectrum for each of the chemicals based on their mass alone. And the masses, because again, it's shooting ions through those different compounds. So let's say you have nonanol that comes through here. The ion source, it's going to ionize nonanol to different cations, and it's going to put it on, or it's going to send it to different parts on the detector, and then that's going to be determined and compared against a database already pre-programmed in the computer, and then that just converts that to the actual chemical name, if that makes sense.
So the molecules are fragmented by the ion source, and molecules will fragment depending on their shape and size, right? And so you get a representative or a peculiar, a specific fragmentation pattern for different molecules, and that's what you have in your database. So when you have a molecule whose fragments match in terms of mass and intensity to the molecule in the database, then that's how you get your qual factor. Does that make sense?
Yeah.
It'd be good to, talk through that, yeah.
Answer, but
All right, any other questions?
I have one last on my part. So these chemicals that you've identified, 5, do you know anything about them? Like what kind of chemicals they are? Are they related to some particular function or something? What's
Yeah,
their
so
biological role, I guess?
we've
Like, are they
looked-
significant in any way?
Yeah, we haven't seen anything, and that's actually, I'm glad you asked that, because some of the times we'll get a compound, and I think it's called like Lilial or something like that, and if you find out, like if you match it, I mean, if you just Google it, actually, it's present a lot in perfumes and stuff. And so one example, there was this girl, and she was wearing a lot of perfume, and I mean, I still rinsed off her arm and everything, but it really strong, and it showed up in one of her top 5 chemicals.
Can you please bring that table again, the 5 of them? Just wanted to take a one last look.
Yes.
It seems like these are mostly alcohols. I mean, not mostly, two of them at least are alcohols.
Well, when it ends in AL, it's actually a what, Rebecca?
Yeah, we have the aldehydes and then there's
Aldehydes.
the ketone.
Oh,
Sure, yeah.
oh, I'm sorry, not alcohol, I'm sorry, I didn't want to do the chemical, very chemical. Yes.
But they're all pretty similar, aren't they? As in they could have been fragmented and all factors could have allowed them to
Well,
miss.
so we've checked that, yeah, and based on the time that it came out of that column, because they're all racing now, right? They came out at completely different times, so they couldn't have been the same chemical.
So the top or the bottom chemicals are aldehydes, the bottom two are aldehydes. The largest, most complex thing in the middle, what is that? It has an alcohol group, but has some ether groups there as well, right?
Yeah, it's got some ether groups and
Second to the last one is a diene with a ketone on it. And the top thing is, I don't know, right? Or Dr.
Dr. Cornwall said, like, he kind of threw a guess out there, but he wasn't sure.
I mean, it says right there oxime, so I guess. Okay, any other questions? All right, let's thank Rebecca one more time.